All right, guys. So any questions so far regarding this lecture that we did last time? I'm going to be posting a few lectures that we have recorded last time. Let me know if you have any questions on that. Okay, good. So what we will do today is we're gonna solve a few problems from chapter 13. And we're gonna start by this pulley system that we have. And we have a 50 kilogram block A and a 15 kilogram block B, and they are released from rest. We have to find the velocity of block B after 2 seconds. So here we have two rigid bodies, right? So basically we would have to do two free body diagrams, all right? Okay, so we're gonna do a free body diagram on B, right? And we're also gonna do a free body diagram on A. Hey, let me put it here. Okay, and on B, we are going to have some acceleration diagram. And likewise on A, we are going to have some acceleration diagram, right? So we said here we're gonna put external forces. Here we're gonna put inertial forces, right? Can someone help me out and tell me what are the external forces that are applied on rigid body B?
It's weight and the tension on the cable.
You have the weight, and let's call it MBG, and then the tension in the cable, right? What is the tension here? Is it the tension in the cable, or if the tension in the table is T, what is the tension that is applied on block B? What is the tension in this piece here, in this cable?
Do we need to make a diagram for D?
Oh, well, let's say the tension in the cable is T, right? Then what is the force applied on this cable? This cable right here. So basically, we have a pulley, right? And then we have tension, right? And then we have a tension here, and then we have like tension in the middle, right? So we have T, and then T. And then obviously this is going to be equal and opposite. So what is this guy here?
3T.
3T, right? You guys all agree? So what is the tension that is pulling on this block? Because, you know, this rope here is not part of the actual rope, right? This is separate. So if one here is, if I make a cut on this pulley, basically, then this guy is 3T. You guys all agree?
Yes.
Okay, so I have 3T here, and then I have MBG. All right, now how about the acceleration? So here, what we have to do is we are going to, do we know the direction of the acceleration now or no?
We can assume that since A is heavier than B,
yep,
so
well,
it's going to go in the opposite direction.
Yep, well, we can assume it, right? We can assume it, okay? Let's assume it downward, okay? We don't know, so we're gonna assume it downward. What I'll do here is I'm gonna, okay, so if the acceleration of B is AB, then what should be this vector be here? MBAB, right? This is where we put MA, right? Okay, MBAB, all right? Okay, what I will do is now let's actually do the free body diagram on A. What are the forces that are applied on A?
Also, the weight and its tension, and the tension on the cable.
Okay, so the weight is going to be M, A, G. And then how about the tension upward? Is it going to be 3T, 2T, or negative
T.
1? T or negative T?
It's upward, so it's T.
Why is it upward?
Because the cable is holding A.
Because the cable can only handle tension forces, right? The cable cannot handle compression forces. If I basically, if I put it like a cable like this, right? The cable cannot do like compression, right? It can do like tension. مظبوط. Tension, yes. Compression, it can. مظبوط. It's not resisting me, it's only doing tension. Okay, so the cable can only do tension forces. So that is why tension is upward, and which makes sense, right? Based on that. How about here? So here is what. So if I say that I can basically assume whatever that I want here, right? For the acceleration of A. I can do here like, MA, right? But I know that the acceleration of block A has to be related to the acceleration of block B, right? What do you think the relationship is going to be here between the acceleration of A and acceleration of B? So obviously, if B is going downward, then A has to be going upward, right? Now, if the acceleration of B is AB, then the acceleration of A is, what do you think is going to be in relation to the acceleration of B? Is it going to be 3 times the acceleration of B or 1/3 of the acceleration of AB?
1/3.
1/3. Why is that?
We did an exercise before which is similar, and we did the sum of the length of the cables, and we
Yep.
derived it, and
Yep.
we got to the end that it was 1/3.
It was 1/3. And you can also look at the number of the cables. So if the tension is tripling, then the acceleration is going to be reducing by 3. In a sense, basically, you can look at this figure right here, right? And when you are doing this mechanical advantage, basically, right? So whatever tension that you are putting on A, basically, this tension here is going to be 3 times on B, right? It means that A will basically be moving longer distance to be able to create that tension on B, right? So basically, I'm amplifying the force that I'm pulling here on this end, right? So you're amplifying the force by 3. It means that the velocity here should be by 3, divided by 3, right? No, that's what it is, right? So here, if I'm amplifying,
said انه it should be divided by 3 بس we divided A by 3 مش ال AB by 3.
Yeah, so AA is actually equal to, you're actually right, yes. So it's actually 3 times, right? So if block B moves a little bit, block A is going to move much more.
Yes.
Thank you for, yes, exactly. You're actually right. So it's going to be 3 times AB, right? This is actually acceleration of A, right? AA. This guy is AA, right? Another way to do it is basically you can do whatever that we did last time, right? By doing this arrangement on that pulley. Okay, ultimately, if you multiply here 3t by AB, it should be equal to t times 3AB, right? So kind of confirming the same work is being done, but not at the level of acceleration, at the level of position. So 3t times the position here has to be equal to t times this guy, right? That's how we can also confirm it. Okay, so now we're good here. What is the next step that we have to do?
Sum of the forces is equal to MA انه بنجمعهم.
Okay, sum of the forces is equal to MA. How do I do that?
On each block alone.
Exactly. So, Newton's law, sum of the forces is equal to MA. This applies on every mass, right? On every mass. And also, if it applies on every mass, then it applies on the whole system, right? You can basically add them up, but it would be like a linear system or something, right? If the equality is available here, like, if I have A is equal to B and then C is equal to D, then A plus C is equal to B plus D, right? So I can do the whole thing and then I can do individual blocks. We're going to do individual blocks here. And this is how we're going to do it always. So what I'll do here is I'm going to sum the forces. Okay, I'm going to treat my upward direction as positive. And I'm going to do B, basically. Here, I'm summing the force on block B. What do I have on block B?
3t minus mbg.
3t minus mbg is equal to what?
Minus mbab.
Okay, very good. So now we're done with the first part. Now, what is the second thing that we have to do?
Sum of the forces for block A.
It's going to be equal to what? T
T minus mag
is equal to what?
3ab. MAAB.
Exactly, times MA, right? That's very important. Okay, so the goal is we're trying to find the acceleration of B, right? How can I find the acceleration of B based on this? So how many equations do I have here?
2.
What? And how many unknowns? 2
Also
unknowns.
2.
Which are what?
T and AB.
Yep. So I can take T from here and then I can plug it here, right? So T is equal to how much? MAG plus 3 MA AB, right? So from this here, I got that, right? Then I'm gonna take this guy and then unplug it here, and then I can use this to be able to find the acceleration of B, right? So 3 times T, which is MAG plus 3 MAB minus MBG is equal to MB AB, right? How can I find AB here? What is AB? So I'm gonna factor it out. So I have 9 MA, 3 times 3 is 9 MA, and then here I have plus MB. You guys agree? And then if I put this guy on the other end, I'm gonna have MBG, right, minus 3 MAG, correct? I can rewrite this. I can say that AB is equal to MB minus 3MA divided by 9MA. Okay, so here what we did is we just found the acceleration of B, right? And the acceleration of B is equal to MB minus 3MA divided by this guy. So if ME is equal to 3MA, what happens?
There will be no movement in the system. Still zero acceleration.
There will be zero acceleration, which makes sense. Why is that true? Because here basically we're amplifying the load, right? So whatever tension we're putting here, we're amplifying the tension by 3, right? So for me to be able to balance whatever tension that I put here, I have to put 3 times that weight, correct? So I'm amplifying the weight by 3 here. So I basically have to put 3 times the weight that I have here in order for me to balance the system, right? Which makes sense here, right? So the acceleration would be 0 only and only if MB is equal to 3MA, right? If the weight that I'm putting here is less than what I'm doing, then how do you think this will go, right? So if if I'm putting MB 3 times A, it will balance, right? If I'm putting more, it will go down. B will go down. If I'm putting less, then B will go how? Up, مش هيك? Right? If I'm putting less than 3 times the weight that I'm putting here, and this guy will go up, which makes sense,
Yes.
right? Because we assumed the acceleration of B to be in that direction. So if AB is positive, so whatever value that I plug here, if this guy is positive, it means that the direction that I put here is correct, basically, right? If whatever value that I solve down is negative, it means that this arrow will actually flip direction. Does it make sense? Okay, guys, are we good here?
Yes.
Okay, let us find the
دكتور
acceleration.
فيك تعيد كيف عرفت انه الاي اي هي 3 اي بي من دون ما اعمل اللينث وهيك؟
Yeah, sure. Absolutely. So one thing we can do is we can do what we did last time was the rope, right? We can set the rope, we can do the length of the rope, etc. But there is another quick way. If you actually make a cut here, right, where I'm putting the mouse, you will see that if you have a tension here, you're going to be pulling this block B with 3 tension, 3 times T, right?
Yes.
Okay. Okay, so we can actually use here the concept of work if you want, right? So the work that is done, right? The work is the force times the distance, right? So the work that I'm doing on the external work that I'm putting on B is what?
3T.
3T, yep, times some displacement, right? Let's call it that. Do you agree?
Yes.
Work, yep, on, okay. So this is the work that the tension is doing, right? So 3T times that, right? And the tension is also doing work on A, right? Which has to be equal basically to this work, which is going to be equal to how much?
T times SA.
Exactly. Here taking like the absolute value of the work, right? So T and T will cancel out. So this is a small deflection, right? If I divide this by, you know, dt, and let's go by dt, what do I get? I get 3 VB is equal to VA. This is as absolute value, right? Absolute value of the velocity. Or 3 times acceleration of B is equal to acceleration of A. Mazboot, right? As absolute value, right? And so basically, I know acceleration of A will always be equal to 3 times acceleration of B as absolute value here. But here, if we look at the direction, if B is going down, obviously it's going to be going up. So, right? So if I assume the acceleration of B is AB, I know acceleration of A has to be 3 times, right? As absolute value. And the direction has to be going upward. This is the easier way of doing it, right? The other way of doing it is basically we can do the cable, right? And we can do the cable, obviously. So how do you do the cable? Basically, we have this guy. We have a pulley down here. And then this guy is actually connected to another pulley. This guy is A. And this guy is connected here. And then this guy is, okay, let's actually put it here. And then this guy is B. Right? We said we're going to do a reference, right? A datum reference for this.
بس البي لازم تكون فوق الاي معي.
It doesn't matter. It doesn't matter, right? Because you are basically connected to the center of the pulley, right? And here we're only looking at the velocities and acceleration. We're not looking at the positions, right? So if this guy is SA, right? We're gonna basically reference the pulleys, right? This guy is gonna be what? SD, right? And then this guy is gonna be what? SC, okay? So if the length of the cable is going to be equal to what? So I can start from here, right? So it's going to be equal to SA, right? So this is the first part. Okay, plus what? Can you tell me? Plus I'm going to add this rope, right?
SD.
SD.
No, SD minus SC. Or SD actually, yeah, plus SD. Yep. Okay, plus
Then
what?
SD minus SC.
Plus 2 times, plus this guy, right? 1 and then 2, right? Plus 2 times SD minus SC. Okay, if I differentiate this whole thing, what do I get? That's 2. 0 is equal to VA plus VD plus 2VD. Derivative of VC is 0, right? If I differentiate this guy one more time, I'm going to get 0 is equal to AA plus 3 AD. And you know that the acceleration of D is equal to the acceleration of V, right? Why? Because the cable here is linearly related, Mazboot. You agree or no? So basically SB is equal to, if you take basically SB here, SB is actually equal to what? Is equal to SD plus some constant here, right? Plus let's call it LC, right? So the velocity, yeah, so VB is equal to VD and then AB is equal to AD. You don't even need to tell me this because we already see that, right? So these two are related by a constant distance. So 0 is equal to AA plus 3 times acceleration of the block. And that's it, right? So the acceleration of A is equal to minus 3 times acceleration of the block, right? And that is what we have here, right? The acceleration of A is 3 times acceleration of the block, but it is in opposite direction. So the minus vector is basically showing that, right? If I put the vector in the opposite direction as B, then I no longer need to put minus here. It would be a big mistake if you actually put a minus here. Okay, is this all good?
I have a question.
Yep, sure.
Okay, when we were taking the length of the
I think you're breaking up. Hello?
Yes, Sam.
Yeah, you're breaking up. I didn't hear your question.
Yeah, I was saying that when we were taking the length of the cable, why
Yep.
didn't we consider SC as well?
Why didn't we consider? We did consider. So it's SA to L is equal to SA. This is the first portion of the cable plus SD مظبوط plus 2SD minus SC. 2SD minus SC. So this portion and this portion.
هو قصده البورشن اللي فوق.
This guy?
في portion.
That's not part of the cable. This guy is not part of the cable, right? Right.
This is only a rope connecting the two pulleys بس صح؟
Yeah. I'm looking at the cable that is changing basically, right? Dynamically.
Okay, clear.
Okay, so make sure you guys are solving the assignments. I have a hunch that you guys are, some of you are doing it, but some of you are not actually doing these assignments. And I mean, if you are looking to pass the course, then you have to be doing the assignments. There's no any other way around hard work, right? If you want to make it, the only way to make it is by working hard, basically. Right, not just here, but later on. If you want to, have a successful career, if you want to make a lot of money, if you want to whatever, you have to be working very hard. There is no like shortcuts, basically. Okay, example 4. We have a tractor basically that is used to lift this 150 kilogram, payload, and the rope length is 24 meters. If the tractor is traveling to the right with an acceleration of 3 meters per second square, it has a velocity of 4 meters per second, and SA is 5. We have to find the tension in the cable. How can we do that? If we do a free body diagram, we'll see that we'll have a tension. We'll have MBG, and then we have here what? MBAB, right? If I sum the forces in a vertical direction, I'm going to end up with T minus MBG is equal to MBAB. So the tension is going to be equal to MBG plus AB, right? But the problem is we don't know AB. How can I find AB?
Can we also do a body diagram on A?
Okay, what about if I give you guys, 5 points on your first midterm? So the first person that can actually solve this problem, I'll give him 5 points on his midterm, but you basically have to be able to solve it fully. How can I find the acceleration of B based on this tractor? So you can only propose your solution only once, you know what I mean? And then the first person will get it fully correct, basically. Just the method, no need for the calculation. I'll give him 5 points on the first midterm. I'll give you guys maybe like exactly 3 minutes. So it's 11:25. At 11:28, basically, I will see what you have.
بس دكتور ليش التراكتور ما عنده ويت؟ ليش مش حاسب له الويت؟
Well, I'm not gonna answer it because let's wait to see if someone knows it. I don't think we need to actually know the weight of that, right? We're just trying to get the acceleration, the upward acceleration of the block, right? That's what we're trying to get. Okay, and yep, I'll give you guys. We have 2 more minutes, basically.
Can I try?
Yeah, sure.
Okay, so if we do the body diagram of the tractor, we have T, tension of the table, of the cable, and mg downwards. This is equal to ma, or A in the horizontal, which is equal to 3 meters per second, or 3 meters per second. But the weight doesn't matter because it's vertical and A is horizontal. So we can find the relation between A and T. T is also equal to, from the body diagram of the block, T is equal to MBG plus AB.
Okay.
And we have the vertical length, which is 12. We can find the angle between T and the horizontal, and we can find the relation between it and A. And it's here cosine T, and this angle is equal to A of B.
But the problem
of
is, yeah, but the problem is that, okay, so this guy is here, right? The block is here, let's say. But this guy is actually moving, right?
Yes.
I know at this point, basically, we'll have an acceleration, right?
Yes.
Like that. AA. But this guy will actually move, right? So this guy is actually
Yes.
changing this. And then this guy is
Yes,
going up.
I have T in function of.
I have AB. I have AB. I'm trying to find this acceleration. So I have
But sir, I
AA.
need to find first the acceleration, then I do a projection on the y-axis. Then I get T.
Okay, so guys, so this is a kinematics problem, right? I don't think the forces here has anything to do with relating this acceleration to this acceleration.
That, Doctor,
This is a purely kinematics problem.
Yes,
And-
we have
can I try?
T,
And
we
then
have الvertical. Vertical does not change. ففينا نجيب شو اسمه axis.
so you see what I'm saying, right? So basically, I have a rope
Yes.
going all the way down, and I'm putting this point with some acceleration. I'm trying to find the acceleration of this guy going upward. Yeah, you can try.
Yes, we have the acceleration at A.
Okay,
We integrate it, we find the velocity,
okay,
and then we find SA.
okay.
Then we have that the length of the cable is equal to L.
Okay,
We can project it on this, so it's square root of SA square plus 12 square plus 12 minus SB.
okay, SA squared plus, okay, plus what?
Plus 12 square, square root of SA square plus 12 square,
Okay, is equal to
which
what?
is equal to the length of the inclined cable.
Which is equal to how much?
24.
لا كله 24.
Equals
24 minus SB.
minus 12 minus SB.
Okay,
Because here SB is
what should I write here? Here, I want to continue this.
it's equal to 24,
So here,
which is
20
the length.
minus SB. 24 minus SB يعني.
so okay, so you have SA square plus 12 square is equal to, you're telling me 24 minus SB? Is that what you're telling me?
بس square. All of it.
minus 12. Minus 12 كمان.
Is that what you want to tell me? Like this?
مش all of it squared.
Like that?
No, Doctor, أنا كان قصدي 24, which
Okay.
is the length of the cable,
Yep. Mm-hmm.
is
24
equal
is equal to 12 minus SB.
yes, 12 minus SB plus square root of SA squared plus 12 squared.
Okay. So رجعت لي okay, last time. Okay, so sorry, I
Okay, 24
Uh-huh.
is equal to 12 minus SB plus square root of SA squared plus 12 squared.
Okay, so إذا بجيبها هيدا لهون بتصير what? You're okay, 12 plus SB square is equal to SA square plus 12 square. Yep, you're actually right. Okay, so I'm gonna okay, so what was your name?
Simon.
Simon's Lab, right? Okay.
Yes.
Okay, so I'll add this. I'll add 5 points. So okay, so he got it right basically. Another way of actually doing it is, so we know this distance here is 12, right? Right. So the distance here, assuming like it's a, so that distance here is going to be what? That distance is going to be equal to SB, right? So the distance from the bottom to the center of this guy is going to be SB. Then the distance from here to here is going to be 12 minus SB, right? So this guy here, this portion of the rope is 12 minus SB, right? You guys agree? This guy is SB, this guy is 12, then this guy has to be 12 minus SB. And I know the whole length of the rope is 24. Okay, so the length of the inclined portion is 24 minus 12 minus SB, right? So 24, the whole length of the rope, minus that portion. So 24 minus 12 minus SB. So 24 minus 12 is 12, right? Minus is plus SB, right? So now if I do this Pythagorean, I have SA squared plus 12 squared is equal to 12 plus SB squared, right? Which is what he actually has. So SA squared plus 12 squared, which is this guy, is going to be equal to 12 plus SB squared. So 12 plus SB squared. I'm not sure how he basically did that, but that, okay. Okay, guys, so we're good here. The other portion is we need to find the acceleration, right? We need to find SB double dot. Do you guys agree? How can you find SB double dot?
Which derivative of this?
Yep, exactly. So we're going to differentiate that. If you differentiate that, what are you going to end up with? So 2, right? 2 multiplied by this guy prime, which is SB prime, multiplied by 12 plus SB is equal to 2 SA prime. Okay, good. We probably need to know the SB prime, I think, or yeah, we probably need to get the SB prime as we get the acceleration. So if we want to find the velocity, SB prime is going to be equal to SA prime divided by, so I'm going to cancel out the 2, 12 plus SB. Okay, so we have now the velocity. How about the acceleration? We're going to differentiate this one more time. If I get the acceleration, can someone help me out to get the acceleration?
12 SB double dot.
Okay, let's start with the first one. SB double dot multiplied by 12 plus SB plus SB prime squared, right? Is equal to SA double dot plus SA prime squared, right? So SB double dot is going to be equal to these guys. So SA double dot plus SA prime squared minus SB prime squared. The whole thing is divided by 12 plus SB. Okay, so SB double dot is actually, so what is the tension in the cable? Is going to be equal to MB G plus,
لحظه دكتور
yes.
مش اس اي نحن عنا اياها مش اس اي عنا اياها 5
Yep, yes.
اوكي واس بي نحن ما معنا ما نجيبها اس بي.
How can I get SB? I can use this, مش هيك؟ I can use this relationship.
اوكي هلا يعني هسه نحن شو قصه شو عم نعمل؟ ليش عم نعمل هي كلها اذا بدنا اس بي؟
We need SB double dot, right?
No, we need the okay with acceleration. طيب okay.
We need acceleration, and then once we plug the acceleration into this equation, we can find the tension in the cable.
Okay.
Okay, and then the only way for us to be able to find the acceleration is by actually doing this process, getting the kinematic relationship. Some people call it constitutive relationships. We use that to find the position, velocity, and also acceleration. I'm not going to do all the detailed math here because I think this is pretty basic for you guys to do, right? The first step is you want to find SB. How do you find SB? You find it from here, right? So let me just quickly do SB because we only have 2 minutes left on the session. And I think we're going to be done probably now. Well, how much time we have? We actually have about 10 minutes left. We'll open another session basically. Gonna solve a few more problems. Okay, if you want to get SB, basically you have 12 plus SB squared is equal to SA squared plus 12 squared. How can I get SB? Do the square root, right? So 12 plus SB is equal to square root of SA squared plus 12 squared. Now I can move this guy here, minus 12. So SB is equal to, we know SA is 5, so 5 squared plus 12 squared minus 12. Okay, guys, we are good here. I'm going to end up this session, and then we will start a new session just like this one, and then do a few more exercises.